you're seeing my screen, 2x minus 5 over 6 minus 3x minus 4 over 8 equals 0. Is this the first question you'd like us to look at today?
Yes.
Fantastic. Okay, this probably looks more difficult than it actually is. It's a linear equation. You're just solving for x. You want to eliminate the fractions.
Right.
So you're looking for the least common multiple of 6 and 8. The reason is the least common multiple, you don't have to do an extra division later on. If you don't know the least common multiple or you don't want to figure it out, you just multiply 6 times 8 and get 48. But that is not the least common multiple in this problem. Sometimes it is, but not in this problem. So do you know what I mean by least common multiple? And if so, can you tell me what it is of 6 and 8, please?
Would it be 2? Like you could factor out 2 out of all of it and then.
So very often what you just told me is the greatest common factor, which is related. It's like a cousin, we'll say, but it's not the least common multiple. So least common multiple is like this. You go out by 6 with 6, so you get 6, 12, 18, 24. And with 8, you do the same thing, 8, 16, 24, and you look for the first number that is the same in both lists. That's the least common multiple. Now you've done this before, you just don't remember.
I've done it before.
Yeah. And
it's been a while.
Whether it's first day of school or just, hey, I haven't done this math in a while, so give me some grace here. We're going to do that. All right, so now the reason you find that number is because you're going to multiply both sides of the equation by that number. So I'm going to rewrite the equation here, 2x minus 5 over 6 minus, I'm going to leave a little space there, 3x minus 4 over 8 equals 0. And you're going to multiply, get rid of that. We're going to multiply everything by 24. So I like to show that here. Now it's everything. So even this 0 gets multiplied by 24. And it doesn't matter whether the 24 is on the left or the right, you're still multiplying in.
I see.
All right, now on the right, it's 0. No big deal there. Anything times 0 is 0. This is something that'll help you with the SAT. Have you taken the SAT or ACT yet?
I took them last year, but
last year. Okay. So it's always better to divide before multiplying. You might wonder why that is. When you multiply, the numbers get large very quickly. When you divide, the numbers get small. Smaller is easier to multiply, add, subtract, everything. Reason I bring up SAT is that's something you'll see on there where if you divide first, it makes things more manageable. So what I mean by that is 24 divided by 6 is 4. So it's 4 times 2x minus 5 minus 24 divided by 8 is 3. Just as I mentioned, the numbers get smaller, more manageable.
Right.
Rather than 24 times 2 is 48, x minus 24 times 5, maybe you got to calculate, maybe you don't, that's 120. That's not ideal.
Right.
But what I have now here is manageable. So if you can remember that, and if you can do a few problems where you get comfortable with that idea, it will save you a ton of time. The more math you take, the more math, physics, engineering you take, you will want to use this approach. Okay. So now we're just going to use the distributive property. We're going to distribute that 4 into both terms. So we got 8x minus 20. The next part here, I prefer to treat this number as -3 that you're distributing in. How do you see it? So some students will say, well, it's plus minus. I don't have an opinion anymore, but as a student, I want to go with what you like. Do you like to change it to plus minus, or do you just see it as a -3 already?
-3. Okay.
So you're taking -3 times 3x. So there's this like intermediate step, which most students don't write, but it's -3 now times -4. What I want to get you to is this next line, which is -9x, -3 times 3x, -3 times -4 is 12. This is what we need to get you to.
Yes, sir.
Okay. At this step here, you're going to combine like terms. So you got an 8x and a minus 9x. That gives you minus x, minus 20 and a plus 12. This is a minus 8 equals 0. A couple of ways you can do it from here. I would add x to both sides because I see that it's going to be positive on the right, and that means that x is minus 8. You can also add 8 to both sides and then divide by negative, and you get the same answer.
Right. Okay.
All right, now this kind of question you will see on like math placement tests because of the fractions, just it's deceptive in its difficulty. It's not really a hard problem once you know to find the least common multiple and then cancel with the denominator, but it is. Now, the other thing is it's tough to check. Like you couldn't really go back to the original check easily to take a little efforts. You want to really be comfortable with your steps along the way.
Okay. Thank you.
All right, now, do you want us to do another one like this? Do you want to wait and do the other problems first and then come back? What should we do from here?
Um, can we do another problem like this?
Yes. Now, while I'm looking for one, could you tell me, are you taking the same math class as last
Um,
semester?
Technically, no. In the
Okay,
transcript, it's counted as a different class as pre-calc trig.
okay,
Last semester, it was trigonometry, and now I'm taking pre-calculus. So
I see. Same teacher, same
same
time?
teacher, yes.
Okay. I asked because this is like easier than what you're doing at the end of that last semester, and yet it is pre-calculus. It's the beginning. I see the 1.1. So anyway, that's good. That's kind of you're easing in, you're not like going back to super difficult stuff here.
Right. Yeah.
Okay, so let's look at 26. You've got to find the least common multiple now of 3, 4, and 2.
Mhm.
And like I said, if you don't want to find that, you can just multiply 3 times 4 times 2, which is 24. That is not the least common multiple, but it will work. Could you try to find the least common multiple for us, though?
Is it 12?
It is 12. And that's what we want to multiply everything by. 12 times x plus 2 over 3. So there's implied parentheses in the numerator,
Mhm.
plus 12 times x minus 1 over 4 equals, and then you can put the 12 on the left side. If you need to, you don't have to have the fraction here. I'm sorry, the parentheses here, but the key is you're multiplying everything by 12. It's not a choice. Everything gets multiplied by 12. And like we just
Right.
talked about, you want to divide before multiplying. Now, do you want to try solving it from here, or do you want to see me work out the rest of this?
I think I can solve it.
Okay, now if you've got paper, why don't you try solving it, and I'll jump in here in 30 seconds and start working it out, but try to avoid looking at the screen to see how you're doing on this one.
Yeah.
All right.
x equals 7.
You got it. Now, do you think the answer is always nice or friendly, as we see here?
No, I remember in class he said if we did something wrong in the equation, we could get an extraneous solution. Is that correct?
Well, so that's where this is leading you to, but that's not where we're at in this grouping.
Hmm.
But the reason so let me just make another comment here. The pages you scanned over, they're the teacher edition. They've got the answers in there. You
Right.
notice like the ones above are fractions. They're not always nice. So just be prepared for, but if you if they do work out, they work out. I guess I'm just trying to get you to realize not every math problem works out friendly or nice.
Right. Yeah.
Now maybe we'll see that in we will too. So let's move on to here in 1.2. Yeah, these are good. Okay. Now this is gonna, excuse me, this is what you were referring to. How did economics or your econ class finish out for you last year?
I brought my grade to a D from an F, so that's
Okay. The direction's good, right? If you had maybe more time, maybe it would have gone up even higher.
maybe yeah. But
Yeah. Okay. Well, did you like the class? Did you enjoy the topic?
yes.
Okay. That's good to hear. Sometimes the grade doesn't demonstrate like what you took away from the course in terms of like its value to you in life.
Right.
Okay.
Okay.
Okay. So when you see a problem like this, and what I mean by this, variables on the bottom. You see how there's a variable on the bottom? There's actually a variable. It's over here, 3n, and then over here.
Mhm.
That is different than the previous problems. If you look back at the previous problems, these are numbers on the bottom. Numbers on the bottom. Okay. When
Okay.
the variables are on the bottom, you should do the following first. You should set the variables on the bottom, or the variable terms, basically the 3n and the n. You should set them equal to 0. Okay.
But isn't it bad for us to have 0 in the denominator?
Yes, because what we are finding what we're finding is what's called the domain, but we're finding the excluded values. So go ahead and just follow this for the time being. What this really means is that it cannot be these values. So let's just say you work out your problem, we work this out on the left, and we get a solution where n is 0. We've already shown that n cannot be 0. We are saying out loud that n cannot be 0.
Right.
It's excluded. Now, what a lot of instructors have you do is they wait until the end to try it. They're like, no, just solve it and then put the answer back in. And if you get division by 0, then it's excluded. We should be better than that. We should know before we start this problem what it can't be. Like if you get a food allergy, you don't wait until you eat the food to find out that it's got something that's bad for you. You probably
Right.
ask first. That's what
Yeah.
we're talking about here. It's like, no, let's figure out like what it can't be so that we know that what we know what we're looking for. Okay, and it'll make more sense when we do some other problems, but we'll go from there. I'm actually looking, none of these are excluded, so it doesn't apply to this part, but if we looked at like problem 21, you'll see that there is an excluded value, or that 2018, 21. I don't know if you have access to your PDF. That little symbol here, that this little symbol here, that means a no solution. Maybe you've seen that before. It also
I
means an
have.
empty set. Okay. Okay, but this one has a solution, so we don't have to worry about some of that. But it's like do the right thing, and hopefully, when it matters on a test or quiz, you know what to do. Now, this one's more complicated because you have to find the least common multiple, and it's more than just numbers. So let me reframe the question down here. It's more than just numbers. So you're looking at the least common multiple of 3n, 9, and n. Okay, so this is where it gets tough. It's like, well, what is it? Now you could multiply them all together, but you don't do that. You first look at the numbers. Okay, so what is the least common multiple between 3 and 9?
3. No,
That's
9.
the greatest 9, yes. Now between n and n, it's n.
Right.
Okay, so when you group these together, it's 9n.
So we have to multiply by 9n.
No, that's what you want the bottom to be. So this is a little bit different than the previous ones. It's like it's completely different. So our goal is to make the bottom 9n in all cases. Let me see if I can give us a little more room here. Okay, so my question to you, or that what you should start thinking about, is how do you turn this 3n on the left? Sorry, let me get to where you can see that. This 3n here, what do you multiply it by to get, so I got all this stuff in the wrong place. What do you multiply 3n by to get to 9n?
3.
3. So you multiply the top and bottom by 3. 1/9. This 9 on the bottom. What do you multiply 9 by to get 9n?
N.
Okay, and on the right here, what do you multiply the n by to get 9n?
9.
Yes. Now there are other ways to do this problem. I'm just giving you the approach that I like, that works really well for me. You may have seen something different in class. I'm really not sure. Okay.
Okay.
But this is kind of the standard approach. Okay. And notice it's different than the previous problems because you don't multiply the top and bottom by the same thing. Whereas
Right.
when we looked at the previous problem up here, you multiply everything by 12. Okay. So, yeah, let's just go with that for now. So the top is 15, 5 times 3 is 15 over 9n minus n over 9n equals 9 over 9n. Is it clear how I went from that top line to this bottom line, multiplying each? Okay, very good. Now, do you see how the bottoms are all the same?
Yes.
So when the bottoms are the same, the denominator is the same, you can essentially ignore them. Meaning you can just ignore that and you just focus on the top.
Okay.
And if this is different, just bear with me. Hopefully, you see the value in this. So it becomes 15 minus n equals 9. That's the top. So we've reduced this very complicated thing into something that's not very complicated. And we need to solve for n.
So we would we would subtract 15 from each side and then divide by negative n or
Yes.
negative 1?
Negative 1. So n is 6. Which I believe matches what's the answer in the book. Okay. Now the last little part here though is that you're supposed to take that answer and compare it to this work you did from the beginning. And it's like n cannot be 0. So we didn't get 0, so we're good.
Right.
We can talk about why there's excluded values at some point, but for right now, you figure out what's excluded, you solve your problem, and then you compare them and you make sure that is not the excluded value.
Okay.
So of course, doing one is never enough. No way to be able to know if you understand. So let's look at number 5. Get all down to scroll up or anything like that.
Beg your pardon?
Did you get all this down, or do you want me to scroll up for you to?
No, I got it all done. Thank you.
Okay. I'm getting the feeling maybe you saw a different approach in class. So.
I tried finding it earlier, but I couldn't find it.
Okay.
I think
Right,
we
so
did, but I can't remember what the approach was.
okay. So if you're, I'm sure I don't know any religious orientation, but you've heard of the 10 commandments. I always say in math, there's like 2 commandments. The first commandment is that you cannot divide by 0.
Right.
Like you should never divide by 0. That's why we set the numerators not equal to 0 and not equal to 0, because you can never divide by 0. It's just not allowed.
Okay. Yeah, that would make
Okay.
sense.
Okay. So what we've said here is that n cannot be 0. That's the excluded value. So if we get all done and we find that n is 0, we would say, nope, that's extraneous. And hopefully we will have time to do one so you can actually see this. But for now, we'll just work through the mechanics of it. But I would always tell you to do this first.
Okay.
All right, now you have to get a common denominator. Your goal here is to get a common denominator. Okay, so you look at the numbers 3, 2, and 4. 3, 2, and 4, and you find the least common multiple between them. What is the
Again, it
least?
would be 12, right?
Yeah, it's 12 this time, just like the last problem. Because n has the same exponent, when you look between n and n, it's just n. So those together make 12n.
Oh, man. Okay.
So for understanding, I do show it this way where we actually multiply them, but there's a few other ways that I'll get to in the next problem and see if you like. But it's the same approach. Sorry about that. Let me get that back. Where did it go? There it is. Technology. Okay. So it's the same question. We need to go from 3n to 12n. So it's like, what do you multiply 3n by to get to 12n?
4, right?
4. Top and bottom. Whatever you do the top, you got to do the bottom. And the reason is because 4 divided by 4
Is
is
1.
1. Yeah. Now you're supposed to put a little fraction right there, but you don't have to. They're usually okay with that. Same question, 2n. What do you multiply 2n by to get 12n?
6.
6. And then same thing over here on the right. What do you multiply 4 by to get 12n?
3n, right? Because it's the
3n.
only one without a variable, so it has to multiply it with a variable.
Yes. They have to be like, if you don't have 12n on the bottom, like the whole point of this was so that you got 12n on the bottom in all 3 places. Okay, so on the top, it's 4. 1 times 4 is 4. The next term, it's 1 times 6 is 6. And then 3n times 1 is 3n. Okay. Now, that's very important here. And like for me, I'm okay with you to do the following, which is to just ignore the bottom, basically just write the top. 4 plus 6 equals 3n. There are a few instructors out there who would like you to take one more step. We've kind of already done that though with this whole like division by 0.
Right.
So this is one of those where I would just check with your instructor, or next time you see when do you have math again? Is it on Wednesday?
Wednesday, yes.
Maybe ask him or her to work out one of these problems and then compare, see, okay, oh yeah, it's the same, or oh no, they're doing something slightly different. Let me make sure I understand what they're doing. So 4 plus 6 is 10. You're just looking at the numerators, equals 3n, divide both sides by 3. So n is 10 divided by 3. And that would be very hard to check if you go back and look at the original.
Right. Yeah. He did say something about leaving it as an improper, but if we wanted to, we didn't have to leave it as improper. We could have just made
Leave
it.
Yeah, so leave it improper. Improper is what they expect at the college level. You want to use that approach. No more mixed numbers. Which you, if I were a student, I would ask, well, why did we learn mixed numbers? It's a great
If we're
question.
not going to use them.
I have no idea. I don't have the answer to that. But maybe you had to learn those to understand other things. I'm not sure. Okay, so here's a new problem, number 6. We're doing 4 through 8. Is that right?
Yes.
Okay. So again, you want to set the denominators not equal to 0. And the reason is those are the excluded values. Sometimes there's more than one excluded value. We haven't seen that so far, but that will happen. Like, let me jump your attention to 12. DC 12, or do I need to snip that in?
I see it.
So 12, it says 5x minus 3. You would set that equal to 0 or not equal to 0, and then 4x minus 1 not equal to 0. And you would get different values. You would get 3/5 and 1/4. So they're not always the same. Like that just be the case in these first few.
Right.
Okay, so that's the excluded value. X cannot be 0. Hopefully don't get 0. So I mentioned I would let me bring this down. I'm going to give you maybe a shortcut here. So you got numbers. You got a 1, 2, and a 5. What is the least common multiple between those?
10. 5, 10.
10. And this time it actually is the product of them. 1 times 2 times 5 is 10.
Right.
Okay, it's not always the case, but when you've got an X and an X, your least common multiple between X and X is X. So those together make
10x.
10x. Okay. Right. Now, the shortcut here is your goal is to get 10x on the bottom in each case.
Right.
So rather than like writing what you multiply it down by, you might be able to, after you've seen this a few times, realize like, oh, I'm just multiplying the top and bottom by 10.
Right.
So you can just put that result down here. Like you can skip showing, you don't even have to show this as long as you get the right thing in the top here. So the next one's a little bit harder. Like, how do you go from 2x to 10x?
You multiply by 5,
Which means you have to multiply this 3 by 5.
which would make it 15 over 10x, right?
Yeah. Okay. And then same thing, you're going from 5 to 10x, which means you're multiplying by 2x, top and bottom.
Right.
So that's 2x here.
Okay.
So I'm essentially just skipping a step. We're just not writing it out and then distributing it. That's okay too.
Okay.
So let's continue this problem here. The numerator, we just care about the numerator, so you can ignore the bottoms. 10 minus 15 equals 2x. 10 minus 15 is minus 5 equals 2x.
Mm-hmm.
And then you divide by 2.
Oh.
So you get x equals minus 5 for 2.
All right.
All right, so in the next problem we do, I'll show you the next approach. We're up to 7. Is that right?
I think so.
Let me show you that other approach here. Because it'll make more sense in this problem. So do you remember what our least common multiple was for this problem we just did?
10x.
10x. So here's the other option. You can multiply everything by 10x. And this matches the approach we did in the first section. And I don't like this one as much, but this is like the analogous approach. And if you're okay to divide before you multiply, it does work pretty well. Okay, so let's see that. Let's carry that through here. So when you take 10x and you divide it by x over here on the left, the x's cancel. So it's 10 times 1 minus. Now here, if you divide 10x divided by 2x, well, that's 5.
Right.
Okay. Equals 10x divided by 5 is 2x times 1. So now when you multiply, you get 10 minus 15 equals 2x. And notice this is the exact same line we got here.
Right.
Okay. And so you might say, well, Matthew, that makes sense. Like, why wouldn't I do that on every problem? Well, you can absolutely do this. And I'm not discouraging you from this. It's kind of like the more math you take, the more you get to decide how you want to do things. It gets a little bit more difficult as you go. So let's look at 7. And maybe I can make a case for one way or the other. Now 7's got kind of another wrinkle in it, so we'll have to address that as well. Any questions though before I jump into 7?
I think my teacher taught me the second way where you multiply everything in all at once.
Like this?
Yeah, like that.
Okay. All right. We will use that approach. If you feel like it's too complicated or you get discouraged by it, we've got another approach that we can talk about.
Yes, sir.
Okay. What is this thing that I'm circling my cursors on right here? What is that? Can you tell me?
A whole number? 7.
7. It's not a fraction though, is it?
No.
How do you make 7 a fraction?
In some cases, 7 is a fraction because it's 7 over 1.
Yes, that's what I was looking for. You want to immediately make sure you remember that it's a fraction, that you write it so that it looks like a fraction. That way you don't mistakenly, be unsure how to work this problem. Everything is a fraction until we eliminate it. So you've got to find out the least common multiple. And there are numbers here. It's 1, 1, and 1. So what's your least common multiple for 1, 1, and 1?
That's a hard question. I'm gonna have to say 1.
Yes. We don't want to overthink it. But we got to make sure we get that down. And because it's just x, it's just x. So you do the numbers and then you do the variables. When you get binomials, we'll talk about those if we get up to that next problem. But your least common multiple is x. Okay. Now I've made the classic mistake here, which is I have not first excluded anything. So we need to do that. Exclude. So you have to set the bottom not equal to 0. You do not set the numbers not equal to 0. They only the variable terms. So basically we're just saying like x cannot be 0.
Okay.
So now that we've got the least common multiple, it's 1x or x, that's what we're going to multiply everything by. So we're going to take this 35 minus x over 1x, and we're going to multiply by 1x equals 1x times 7 over 1 plus 1x times 3 over x. It's better to divide before you multiply. Like in this first one here, if you multiply, get 35x minus x squared, then you got to divide. It's just easier to multiply. I'm sorry, to divide before you multiply. So this just becomes 35 minus x.
Right.
The second one, you got ones, the ones cancel. So it's x times 7 plus the x's cancel here, 1 times 3. You can multiply them. You don't have to be as I don't know, explicit as I'm being here. You can simplify as you go. But go ahead and solve this for me, please, and let me know your final answer.
Okay.
I'm sorry. Did you get me a final answer?
No, sorry.
Okay, I thought I heard you say a number.
Is x 4?
Yes. Now we go back, we make sure that's not the excluded value. Like, oh yeah, okay, it's not 0, we're good. Thumbs up kind of thing.
All right. Okay.
Any questions on that?
Um, no, but I got a funny story to tell.
Go for it. We got time.
I think we did this problem in class, and it's funny because in class the teacher messed up the problem, and instead of subtracting 3, he added 3, and so it was like 8x equals 38, and we were like, that doesn't divide. What are we doing wrong? Not
Well,
that
your
it's really.
teacher, the teacher, you wonder, did they do this problem earlier in the day? Maybe they were, distracted. Who knows, right?
Right.
Now, question for you: do you notice when your teachers are different from day to day, or do they always appear pretty much the same to you in the classroom?
What do you mean? Like,
Just their demeanor, can you tell from one day to the next, or is it pretty consistent?
um, for most of my teachers, they're pretty consistent, but like because they're consistent, I can tell when they're different.
Yeah. Yeah, I mean, remember they're real people. Like they probably have, things going on in their personal life, and like, it is so easy. Like I mean, I love this stuff, and I make mistakes when I'm, know better. So it's like, but when you get an answer that doesn't, like, use your intuition, like you pre-calculus is pretty high up in the math world. Like if you feel like something's not right, you're probably onto something there. And that's kind of what I heard too. It's like, hey, this answer's kind of off, we've been getting a lot of nice numbers. Now this one's way off. Use that to your benefit, especially on a test. You're like, that doesn't look right. Work it out again. Ever like what I used to do, maybe this will help you. So if I didn't feel good about the problem, I would look at that problem and I'd write it on the back of another piece of paper on the test, if that was possible, and I'd rework it without looking at the original problem. That way I wasn't biased by all the original steps that I took. So that may help you, if you find yourself in a state where you're like, oh, I'm not sure, maybe there's something wrong.
I see.
Okay, let's look at number 8. Number 8. So just like in the previous problem, this 5 is really 5 over 1. It's a fraction. This time though, and I don't like that they gave you this one because it's kind of a weird binomial on the bottom. Binomial, it's got 2 terms. The number now is the number that's actually out in front. So it's the least common multiple of 1, 1, and 1 again, not this 46. There's implied parentheses in both the numerator and the denominator. So again, it's 1. Okay. Now, the least common multiple, when it's a variable term like this, you're just looking at the 2 terms and you're like, well, are they the same or are they different? Well, they're the same. Okay, so your least common multiple, you have to always multiply the number and then the variables together. So in this case, it's 46 minus n. It's a lot of work to kind of figure out that it's 46 minus n.
I see.
Okay, now this is not the best example to start with, but that's what we've got. So next step, and I've already messed this up again because we don't say what it's excluded to, but we won't worry about that for the time being, is you're going to multiply everything by 46 minus n. So it's n over 46 minus n equals 46 minus n times 5 over 1 plus 46 minus n times 4 over 46 minus n. You should divide before you multiply. If you only take that away from tonight, that's going to save you something later on down the road. Divide before you multiply. So in the left here, actually, let me switch to red. Red's the canceling color. Cancels. Cancels, right?
What a world.
Yeah, it's always important to remember what's left over. This is what's left over. It's nice. I've got the got the digital stuff here so I can make that nice. If you have, colored pencils, highlighters, sharp, stuff, that's always good to use. But you're down to n equals 46 minus n times 5 plus 4. Like that. Is that okay?
Yes.
All right. We're going to distribute this 5 to both. So we have n equals 230 minus 5n plus 4. And then we move some stuff around. So we'll add 5n to both sides. That's 6n equals 234.
Mhm. And
So
then,
divisibility rule for 6, if you don't know this, I'll just share that with you. It's got a 2 and 3 have to work. So this is even, so 2 works. And then you add up the digits, 2 plus 3 plus 4. That adds up to 9, which is 3. All that tells you it's divisible by 6. If you have a calculator, though, you can also shortcut that as well. And you end up
Right.
getting 39 with that.
Huh. Cool.
Okay, let's look at 18. It's very similar to ones. It's because we've got enough time here to do one more problem at least. Is that okay if we do 18 to show you the why we exclude stuff?
Yeah, totally.
Did you have any follow-up questions to this one though before I move on?
No.
Okay. All right, so here's 18. We already got the answer. The answer is the empty set, no solution. First thing you always do though is you always set the denominator not equal to 0, and you get that x cannot be 0. I'm sorry, cannot be 8 because you add 8 to both sides. So
Right.
if we get 8, we know that it can't be 8. Okay, now I'm going to just skip just because we don't have a ton of time. I want to make sure we get the full coverage here. I'm just going to give you the least common multiple, which is x minus 8.
Mm-hmm.
And you can just follow along here. So just like the previous problem, we're gonna get that red pen out. We're gonna cancel out the things that cancel. And because I've got that highlighter, I can easily show you what's left with this minus, this stuff, and the 8. Okay, so you get x minus 8 times 4 equals 8. That 4 you're going to distribute into both. You got to be careful though with this minus though. So it's going to be x minus 4x minus 32 equals 8. Then you can distribute that negative into both.
Mm-hmm.
So now x minus 4x is minus 3x. Subtract 32 from both sides, you get minus 24. You divide by negative 3 and you get x equals 8, and you feel really good about yourself. You say, I'm the best student in the world. And then if you don't do this part, yeah. So if you had a quiz tomorrow and you had gotten up through like problem 18, I would tell you you're going to get a problem where your solution is the extraneous solution. Like that's a test question. That's one they like to put at you because they want to know that not only do you know how to solve it, you know to check your answer, meaning you should be able to go back to the original and realize like, oh, 8 minus 8 is 0. I can't divide by 0. Or that you knew from the beginning, hey, if I get 8, I know it's wrong. But you're not there yet. But you're interested in kind of going into like science, technology, stuff like that as a career field. Is that right? Engineering,
Yes.
maybe. So it's always good to know like the constraints. The constraints of the problem. What do you think I mean by that? The constraints of the problem.
Like, what the range of the answers could be. So like if it's only in between, if it can't be like a certain number or a certain couple of numbers, those would count as the constraints because you can't like, if you get that as an answer, then that's like bad.
Yeah, you have to say like one of our constraints is that I was talking to a guy over the weekend that he was working on drones in the 80s. 1980s.
Well,
And
that's fun.
right, like, so a drone, we don't think a drone's a big deal now, but the drones they're actually um powered by engines, internal combustion engines. Like it would sound like, I don't know if you've heard a lawnmower fired up, or a car fired, like that's probably what it sounded like coming at you, because their constraint was, we need to have a big battery, or we have a big camera that we want to take pictures with, or we're bringing something on this drone, and that was a constraint back then. But now the constraint is like, okay, we want it to be quiet. So don't
Right.
don't bring me a drone that's making a ton of noise, or the drone's got to be able to go up this high. Or constraints just help you to know whether your solution fits the constraints of the problem. And on a much more simple level, it's like, imagine you have a square peg and a round hole.
Ooh,
Can that go in there? No, but we can. But so this is a no, but this is a yes. And
yes.
if our circle's a little bit different, all of a sudden, this is no, and this is yes. So it all depends on the constraints of the problem you're facing.
Right.
Okay, that pretty much gets us to the end of our lesson for today, Joaquin. I am doing an SAT ACT prep class starting this Saturday. This is just it's a preview day, totally free, no obligation. If that's something you're interested in, question for you is, would 10 a.m. or 12 p.m. be a better time on Saturday if you think you would be interested in going?
You said SAT
ACT
prep?
prep class, yeah, for math. I'll cover testing strategies with some of the content of the class every Saturday, but I'm still gauging interest and just finding out, if people actually can make it. That's another, people might say, I love it. Is that something you're interested in? You can get back to me. But if right now, I'm just curious if 10 a.m. would be better for you on Saturday.
Um, I think probably 12 p.m. would be best for me.
Okay, cool.
If I could make it at all, but
Sure. Got it. Okay. Well, thank you so much. I look forward to helping you this semester. I'll send you the notes over shortly, and I'll see you next week. Hope you have a great rest of your night.
thank you, you too.
Okay. Bye now.
Bye.